is the slope of the line. In very simple words, it is the change of the function with respect to certain variable. But my dear, line is a very simple function, say a one-dimensional function. What would we do if I want to find out the change of the complex function, say three-dimensional function, with respect to special coordinates? Then we require an operation, what we call in EMT a gradient. So let us see what do we mean by gradient of a scalar field. Before moving ahead, let me explain you what is the difference between scalar fields and vector fields. My dear, field is nothing but a function of certain variables. If you consider Cartesian coordinate system, then field is nothing but the function of x, y and z. If we are considering the cylindrical coordinates, then it would be the function of rho, phi and z. And likewise for spherical, r, theta and phi. So field is nothing but a function. Let us have a look at these functions. This is a scalar function or scalar field. This is a vector function or vector field. My dear, you must have pointed out the difference between scalar and vector fields. As we all know, vectors must have directions. It must have unit vectors. So this is the vector field and this is the scalar field. Let us assume any room or 3D space for our illustration. Each and every point that is present within this room can be represented with the proper coordinate system. If I am using Cartesian coordinate system, each point can be represented with p, x, y, z, isn't it? And let us also assume that we are given with the temperature of this room as like this. Now you can easily observe that this temperature is given as a function of x, y and z. So my dear, this is called as the scalar field. As you all know, temperature is a scalar quantity and it is the function of x, y and z. So it is nothing but the scalar field. My dear, using this scalar field, we can calculate the temperature of each and every point that is present within this room. Just we have to put the coordinates or x, y and z of that point into this function. For example, if I want to find the temperature of point 1, 2, 3, I have to put x equal to 1, y equal to 2 and z equal to 3 in this function. I will get the temperature. So after getting temperatures of all the points, the graphical representation may look like this. This could be the graphical representation of scalar field. The intensified spots denotes higher temperature, while the lighter spots denotes the lower temperature. Now let us say we are given with the electric field within the room as like this. My dear, it is also the function of x, y and z, but along with unit vectors. So this would be called as the vector field. As you all know, electric field is a vector quantity. Once again, as I said in temperature, we can also find the electric field for each and every point that is present in this room. For example, if I want to find the electric field at point, let us say once again at point 1, 2, 3, then I have to put x equal to 1, y equal to 2 and z equal to 3 in this electric field function, a vector field function. And we can get the electric field at point 1, 2, 3 as like this. This is a vector having certain magnitude and direction. So you know, this can be represented with an arrow having this magnitude and direction. And likewise, the electric field at all the points that are present within the room can be calculated. And if we try to plot such function, it may look like this. It would be a vector function, isn't it?